Hey folks, let's finish up our last little bit here of P3. So we finished up talking about composing functions, and now we're going to get a little bit into logs. So these exponent properties and log properties, and you've seen them before, they're not the easiest thing in the world to memorize, I agree. But welcome to the big leagues. So a lot of the stuff you kind of instinctually probably already know. Like, for instance, you already know that anything to the 0th power is 1. Anything to the first is the same thing, right? A to the first is still A. Exponents multiplied together. Things with exponents multiplied together, you can add the exponents. Division, you can subtract them. And then you get into the log ones. The log ones don't feel as natural, but they're really just the inverse of the other ones. So yet again, the way I learned this, or the way I finally learned this, I should say, is that if you're multiplying stuff in exponents, you can add them up. Well, if you're adding stuff in logs, you can multiply them up. So it's kind of like they're related the same way. So add and mult go together, subtract and division go together. So these properties are sort of like connected to each other in terms of being the inverses. This is the log shortcut, but we have a log base button on our calculator now. So I didn't show you this in pre-calc because I wanted you to know the log trick. But if you go down to log base, you can do anything. So I'll show you again how I did that. I did alpha F2, and then I go down to this one called log base, and then I can do log base 3 of 17, get some crazy decimal. But you do have to know these. You do have to be able to recognize when can I use some of my log properties, when can I apply my exponent properties. And then down here, we already talked about these two. A negative exponent means flip. It doesn't mean put it on the bottom. It just means flip. This is on the top, and so now it's on the bottom. And a rational exponent, the bottom part is the root, and the top part is the power. So the number that we usually reference when we're talking about logs and exponentials is E and natural log. So we could talk about any log, but almost always when they say log, they really mean natural log. And natural log is the base of the number, is the log with the base E, named after my, which is about 2.718. It goes on forever. It's an irrational number. Named after my favorite mathematician, Leonhard Euler. So it's like pi, but it's actually used more. I don't know if I'd say it's more than pi, but anyway, if it appears more often in mathematics than pi, but it's one of those hugely important numbers. All right, so here's just this crazy equation. How would you try to solve this thing? We're going to try to find the exact solution and then give a 3 decimal approximation. So we're going to need our calculator at some point. So you look at it, you might be intimidated by this, I get it, but just overcome that fear and try to break down and see if you can come up with any sort of ideas. When I first did this problem, I looked at it and I said, okay, well, 6 times 3, I kind of feel like I should do 6 times 3, but then I ran into the problem that I noticed that this was 3 to the 2x. So I have to do the 3 to the 2x before I could do the times by 6. So I ran into a problem right away. So I said, all right, what else can I do? I can't divide any of these x's out, so my x's are stuck in the exponents. I'm going to have to log at some point, but I have different logs going on here. Log base 3, log base 2 would have to be applied to kill them off. And either way, I've got the 6 that's blocking it. So I said, okay, what can I do with this 6? Well, then I looked, and 6, something I saw these two, and I related it to this, and all of a sudden I realized that 6 is made up of 2 and 3. So I'm going to rewrite 6 as 2 times 3 times 3 to the 2x equals 2 to the x plus 1. All right, so now my math voice says, what does your math voice say? I don't know. Well, that's one thing it can say, but that's not going to help you get anywhere. So I looked at it and I said, all right, well, I guess I kind of saying that I should have my 3's on the same side and I should have my 2's on the same side. So what I'm going to do next is I'm going to bump this 2 to the other side. It's connected by mult, so we'd kill it with our good friend division. So I'm going to divide both sides by 2. And then here we are. This is our first log property. So now we have 3 times 3 to the 2x equals 2 to the x plus 1 over 2. Well, these have the same base. They're getting multiplied together, which means I can do what with their exponents? Hopefully you said that we could add those exponents together. Now I'm going to put the 2x first. So we could have 3 to the 2x plus 1. And then over here, same idea, except I can subtract them. So that's 2 to the first. So 2 to the x plus 1, take away, or divided by 2 to the first, I would subtract x plus 1, take away 1, and all of a sudden I would have 2 to the x. So something that was pretty crazy before now is getting better. It's getting better. It's not there yet. We still have x's in the exponent, but at least it's getting a little bit better. So what's the only way to get stuff down from the exponents? And that's log. Log or natural log. You could use log or natural log. I'm going to use log or natural log. So then I would natural log both sides. And you notice if I go back to my properties, remember that you could take, if you got something in the exponent, you can take that exponent and bump it out in front of a log. So that's nice in this case because now I have these as my exponents. Actually, I'll rewrite this. So where do we go next? Now we go up here. And I have natural log of 3 to the 2x plus 1 equals natural log of 2 to the x. But now I can take these exponents and I can bump them out front. So I can take this guy and bump them out front, take this guy and bump them out front. And so I have the quantity of 2x plus 1 times the natural log of 3 equals x, natural log of 2. Still looks nasty, but at least we don't have anything up in the exponent anymore. We've got our x's down on the same line. I don't know what your math voice is saying. My math voice is saying I've got to do something with those parentheses next because I want to get my x's together somehow. So what I'm going to do is I'm now going to distribute that natural log of 3 into the group. I mean, if this was a 6 out in front of a parenthesis, you'd distribute it. So don't be afraid of natural log of 3. It's just some number. We don't know what that number is, but it is just some number. So 2x times natural log of 3 is 2x natural log of 3. Plus natural log of 3 times 1 is natural log of 3 equals x natural log of. So suddenly we have something that doesn't have any parentheses. It doesn't have any exponents. Everything's kind of looking a little bit nicer. So what would we normally do if we had x's on both sides of an equation? Well, hopefully you're saying that we would then combine our x stuff to one side and move our other anything non-x to the other side. So I'm going to do a double move here. I'm going to subtract x natural log of 2, and I'm going to subtract it from over here. But I'm also going to subtract the natural log of 3 from both sides. So now I have 2x natural log of 3 subtract x natural log of 2 equals negative natural log of 3. I can't combine these because they're unlike terms, but what does this term have and what does this? They both have an x, so I can now factor out an x. So that would leave behind 2 natural log of 3 minus natural log of 2. Who's keeping x from being by himself? This whole thing. So then I would divide by 2 natural log of 3 minus natural log of 2. And I would divide by 2 natural log of 3 minus natural log of 2. And that would leave me with x equals negative natural log of 3 over 2 natural log of 3 subtract natural log of 2. So easy, right? No, I get it. It is kind of intimidating. It's scary, but this would, I would say, would be the highest level of I wouldn't probably give you something like this. I definitely wouldn't give you something like this on a test or even a final exam. I might give it something on a partner quiz where you guys could come to the board and work on it together. But I like to do examples like this because it really pushes what we know. And if you never see the toughest problems being solved, you never get a chance to make those connections and then try to do it on your own. Now, if this was a free response question, you would stop here. You would leave it like this. You do not want to clean it up. But if it's a multiple choice question, they probably would try to clean it up. And they would then apply the log properties that we applied here and apply them to clean it back up. For instance, this 2 can then go back up to the exponent. So I would have, I'm going to actually change the color here so that we can see what I'm talking about. This 2 then can come back up to the exponent. So we would have something like, what would be a good color? How about blue? Yeah, I guess blue is fine. So I would get x equals negative natural log of 3 over, I'm going to bump that 2 up. What's 3 squared? 9. Take away natural log of 2. Do you see the next move? Do you see one of the log properties that we can apply here? I can't show you how to do it. You have to see it on your own. If you don't start to see it on your own, you'll never make those connections. The next thing I notice is that I've got log subtract log, which means I can condense that into a division. So I would have x equals negative natural log of 3 over the natural log of 9 over 2. And then from there, I couldn't find anything that was better than that. So this to me was as cleaned up as we could get. I mean, you could write 4.5 if that makes you feel better, but those logs don't cancel and you can't do 3 divided by 9 halves, so you're just kind of stuck there. So logs are something that's nice because it allows us to take exponents from the things in the exponent and bump them out front. That's why we like logs so much. So here's this is his little portion. He's talking about that movie Stand and Deliver. I don't know if you've ever seen it, but it's about this calculus teacher. Anyway, this is one of the questions in the movie. Which of the following is equal to the natural log of 4? So can we just add natural logs together? No, right? That's not one of our properties from the other page. It's natural log of 3. This one, I don't know about this one. I might come back to this one. These 3, I'm sorry, these are all things that we're going to study later on in the year. So what he did was he's using, this is the actual problem from the AP test in 1985. So what Corby did was he took these multiple choice answers and he rewrote them in a way that's accessible to you at this point in your calc career. So instead of looking at these, let's go down here. He translated these into a form that's easier for you to understand. So let's go through these and see which one of these is equal to natural log of 4. So we just talked about this one. You can't add logs together. So using that same logic, I'm sorry, if you add logs together, well, how do they combine? I shouldn't say that. I should actually show you what I'm talking about. So natural log of 3 plus natural log of 1 would become the natural log of, we can combine them into 3 times 1. But 3 times 1 is 3, not 4. So let's take a look at natural log of 8 divided by natural log of 2. This doesn't clean up at all. There isn't anything that we can do from here. I mean, you can rewrite this as natural log of 8 times the natural log of 2 all to the negative 1. You know, you can flip it off the bottom, but that doesn't make your life any easier. This is not clean upable, so it's definitely not equal to natural log of 4. E to the 4th minus e to the 1st, that's not even natural log stuff, so we can eliminate that one. And then, okay, this one gets a little trickier. So let's take a look at what would happen if I can take this 4 and I can bump it up to the exponent. So I would have natural log of 4 to the 4th, subtract 3. 4 to the 4th is 64. Natural log of 64, no. 4 to the 4th is 128, I think. Let me just do it real quick. 256. And natural log of 256 is some crummy decimal, and taking away 3 from it will definitely not turn it back into a nice. So no, this is not going to work out either. So by the just kind of figuring out what's it called? Oh, I can't think of what it's called. By eliminating all of these choices, this has to be our right answer. But let's just double check to make sure that it really is true. So natural log of 4 minus natural log of 1. I can condense that into a division problem. The natural log of 4 divided by 1. 4 divided by 1 is 4, so we would get natural log of 4. There we go. So applying those properties, being able to see whether or not you can apply the properties and get the same result is what we're kind of going for here. So let's do this last one. I'm going to encourage you to pause and try to clean up as many of these. See which one of these are equivalent to natural log of 4. All right, let's see how you did. So let's go through here. I'm going to use a different color for each one so that it'll be... I'm going to use pink again for this one. We already did this, but just to review. Natural log minus a natural log. I can condense those into a division problem. Natural log of 4 divided by 1 is the natural log of 4, so this is equivalent. This is equal, so I don't want to cross that one out. I'm trying to find out which one is not equal to. Not equal. So that one is, so we can eliminate that one. Let's do 2 natural log of 2. If you're not doing these on your own, you're not going to get any better at it. So you should be pausing a lot here. Okay, so hopefully you saw that you got a 2 in front of the natural log. That means I can take this and I can bump it up to the top, and I would get natural log. So let me go B here. Would be natural log of 2 to the second. 2 to the second is 4. Natural log of 4 is equal. So I can eliminate that one. We want to find the one that is not equal to, or as many as we can that are not equal to. Part C. Natural log of 16 divided by 2. Yeah, there's nothing I can do to clean this up. I mean, I can rewrite this as 1/2 natural log of 16, but natural log of 16 is not twice as big as the natural log of 4. I mean, let's think, oh, no, I am wrong. This is nice. I can take this from here and I can bump it up to the exponent. 16 to the 1/2. To the 1/2 is the same as the square root. What's the square root of 16? Boom. I like that one, actually. Square root of 16, that is equal. All right, so I caught myself there. Let's see how you did on part D. Natural log of 8 subtract natural log of 2. I can condense that into a single natural log of 8 divided by 2. Oh, this one's easy. That's natural log of 4. So that one is equal. I can also eliminate that one. We're down to the last 3. Notice it doesn't say, I don't know if it'll only be 1. It'll be interesting if it'll be more than 1 in this case, or if it's just going to be one of them is the one that's not equal to. All right, let's try E. E to the natural log of the quantity natural log of 4. Folks, what does e to the natural log do to each other? E to the and natural log are natural enemies. They're the things that cancel each other out. So e to the a natural log will undo each other, and you're just left with natural log of 4. So that one is also equal. I'm running out of colors here. Let's go with brown, I guess. Brown right underneath the orange? I don't think so. How about this red thing? So F, natural log of e to the natural log of 4. Here we go again. Who is the natural enemy of natural log? Natural log and e to the undo each other. So natural log and e to the undo each other, and we're left with natural log of 4. So that one is equal. So by the process of elimination, that's what I meant to say on that other example, we know it has to be G unless it's none of them. So usually it's going to be one of them because it is a multiple choice, but let's just double check. So in the G example, natural log of 4 divided by natural log of 1. Yes, these are two different things. Actually, this is even worse. This is undefined. Natural log of 1, any log of 1, natural log of 1 is nothing. Log of 1 is nothing. I'm going to do a weird base. Log base 72 of 1 is 0. So any log, because the log graph, right, if I said sketch log, pause it, make a sketch of log right there. You have 5 seconds. 4, 3, 2, 1, 0. The sketch of log would go like this, whoosh, and it hits at 1. This is the point 1 comma 0. So if you log 1, you'll get an answer of 0 no matter what log you're doing. So this would actually turn out to be natural log of 4 over 0, which is undefined. So G is the one that fails the test of being equivalent to natural log of 4. All right, so there's our notes. He gives a little warning here at the end. On the actual AP test, the last answer is not always the correct answer. Okay, so that is not always true. I wish it were. It'd be a lot easier for us. But you got to actually go through the problems. He set it up so that you would try each one of these. So that's it for the notes. Good luck on the homework.